Let's take a look at problem 9.13. It's a hypothesis testing problem. Okay, I'll read it to you. Recall that very satisfied customers give the XYZ Box video game system a rating that is at least 42. Suppose that the manufacturer of the XYZ Box wishes to use the random sample of 65 satisfaction ratings to provide evidence supporting the claim that the mean composite satisfaction rating for the XYZ Box exceeds 42. Okay, now I've covered up the answer to B so that we can focus on part A first. A says, letting the mean represent the mean, we're going to use this symbol, this Greek symbol, the composite satisfaction rating for the XYZ Box, set up the null hypothesis H0 and the alternative hypothesis H sub alpha, right, or H alpha, needed if we wish to attempt to provide evidence supporting the claim that the mean exceeds 42. All right, well, here's how we would set it up. The null hypothesis is that the mean is less than or equal to 42 versus an alpha, which would have a mean that's greater than 42. Okay, that's part A. Now, let's read part B. Part B says the random sample of 65 satisfaction rating yields a sample mean of 42.954, assuming that the standard deviation, given by that Greek symbol, equals 2.64. Use the critical values to test the null hypothesis, that's H0 versus H alpha, which is our alternative hypothesis, right? At each alpha value of 10%, 5%, 1%, and 0.1%. Okay, you could also read that as 0.1, 0.05, 0.01, and 0.001. All right, now, here's how you would calculate it. You need to calculate that Z value, and you would take the 42.954, our sample mean, subtract it from 42, and then divide it by 2.64, that's our standard deviation, divided by the square root of our population, which was 65, our sample of 65. So we come up with 2.91. Okay. At 10%, the rejection point is 1.28. A z-score of 5% is 1.645, and a z of 1% is 2.33. 0.001 is 3.09. All right. Now, part C says, using the information in part B, calculate the p-value and use it to test H0 and H sub alpha, so to test the null hypothesis and the alternative hypothesis at each of those alpha values we talked about earlier. All right, how do we do that? Here's how we do it. Since 1.28 is less than 1.645, which is less than 2.33, which is less than 2.91, and then also less than 3.09, that's all our Z values, we would reject the null hypothesis at the 10% level, the 5% level, the 1% level, but not the 0.001 level. All right, and that's because our Z-score falls below the 3.09 level, right? So we fell below the 1.28, 1.645, and the 2.33, but the 291 fell within the range of the 3.09 Z at 0.001.